Mr. Bhattacharya?
Yes, sir. I'm there. Yes, yes, sir.
Sir, professor will come also.
It's your Professor BHAUMIK is joining just now.
It will follow the same pattern yesterday.
Yeah.
Fine. Thank you, sir.
Thank you.
Good afternoon, sir.
Good afternoon. Good afternoon to all of you. Should we start right now?
So yes, sir. I will start now, sir.
Okay.
Very good afternoon to all of you on and there. So now we come to the third session for the third day. That is AR and VR technologies empowering educators and learners by Dr. SUBHASIS BHAUMIK, Professor and Dean, Robotics and Control, IIEST Kolkata, and is a research scholar, Mr. Saptak Bhattacharya. It's a very relevant topic, especially in the time of pandemic. So this will help us to educate our students in a more effective manner, the AR and VR technologies. Now I hand over to Professor BHAUMIK. Sir, yours.
This is visible. I'm showing a PPT.
Yes, sir. It's visible, sir.
Okay. Good afternoon to all of you. And yesterday we started with the discussions on this AR and the VR. And today also this the same topic, this will be continued. And I will not present anything very special for education and training purposes, how the educators and the trainers or the trainers, they are getting benefited. But throughout this presentations, one will come to know that how we are using, the educators are using this AR and the VR systems, and how the trainers are getting benefited through this technology. Like say for example, I am showing that say for examples like education's virtual reality for teaching and the learning situations. The advantage of this that it enables the large group of students to interact with each other as well as within a three-dimensional environment by creating a virtual lab. And most of the cases, whenever we are doing some sort of experimentations on the real systems, only one student can have an access to the machines. Rest of the students, they have either to see it from a distance or they are just as like a spectators only. Okay. So, but in case of an virtual systems, as this is a virtual, so each and every students will have the access to the machines, the virtual machines, and they can do the experimentations by themselves. Like so, each and every students will doing the same experimentations, and they are individually they are working with the systems, and individually they are getting the results. So that is the beauty of this. To the educators as well as to the students. So the educators, they are thinking that they are providing the machines to each and every students, and at the same time each and every students is understanding that they have a machines with them. They are working as an individually, they are working with the machines. And the other advantage is that in the case of a real systems, within a certain time period, only 1 or 2 times you can do the experimentations. Okay. And sometimes also there are many features that they are in the experimentations where which the students may not be able to do it because of the lack of time. But whenever it is a virtual system, so virtually each and every experiment you can do it, and not only that you will do it once or twice, but as many times as you like, you can do the same experiment again and again. So if you have any doubt, okay, or if you have any confusions, or if you want to change the situation, if you want to change the input to see that how the output will change, so you can do the same experiments again and again, you can do it. So the virtual reality is used by the trainers to provide learners with the virtual environment where they can develop their skills without the real world consequences of failing. But if you ask that is this means the virtual systems, this is a real this is a replacement of the actual systems? Do you think that we do not require any actual systems for our experimentations? Or do you think that students in their 4 years of study, they can do all the work in a virtual mode and they do not require to do the experimentation in the real systems? We are not saying that this is a substitute. Okay, this is not a substitute. So real systems, you must have a real systems. So unless and until you have a real systems, unless and until the students works with the real systems, there will be a gap of knowledge will be there. And the real systems behave in a real form. Virtual systems always work in a virtual form. And in a real systems, if you do the experimentation say 100 times, you may have a reading 100 different types of readings. But in the case of a virtual systems, always it will give the same results, like because this is working with some sort of the virtual system is working based upon some mathematical expressions of the equations. Okay, uncertainty is, practically speaking, we are not considering any uncertainty in the virtual experimentations, virtual reality systems. But in case of a real systems, there are uncertainties, and whenever in an experimentation there is an uncertainty, so definitely your results will change. And the students should have a feeling that the results are not constant, but it can vary. So sometimes, say for example, from the mechanical point of view, so in mechanical point of view, we can have a different readings based upon the friction coefficients. Sometimes the friction is less, sometimes the friction is more. Okay, so depending upon the friction, some of the parameters may change, and these you cannot get it in a virtual environment unless and until in the virtual systems you have given the parameter, that is the that is the coefficient of friction value. Okay, unless and until you change it, every time you will get the same results. So here at the bottom, you can see one experimental setups, okay, performance test by the Morse methods, like a one experiments, virtual experiments, how the virtual setups looks like. So one is the tabletop, is a kind of tabletop model, and on the left hand side you have a virtual machines. So on the virtual machines, there are 4 knobs are there. So on the upper side, there are 4 knobs are there. So you can on the knob or off the knob, you can change the knob, or you can put the knob in a minimum conditions, or you can put the knob in the maximum conditions, and then you can see the performance of your machines or the systems. So for that purposes, there are some analog meters are there. Okay, so there is a pointer, you can see it in the white one. So there is a pointer, and the pointer can move depending upon the performance of the systems, or there may be some sort of digital output. You can see on the digital output on the dashboard also. So, and there is also some sort of fuse are there. So this is like a fuse systems, or maybe some other optional devices may be there. Okay, so it looks from the outside, from the students perspective, this particular setups looks like a real setups. Okay, so you can do the number of times you can do the experimentations, and you can see that there are 2 valves are there. Okay, so the valves may be open, valves may be closed, and you can put the valve in a 50% opening and put the other valve in the 50% in the closing conditions. So you can change the parameters, and depending upon the change in the parameter, you can see that how your systems behaves from the different readings. So in this way, you can do all this experimentations part, you can do it. So applications of this AR and the VR in the e-learning process, it's like a say training in the hazardous situations, critical skill training, on-the-job training, compliance training, employee onboarding training, soft skill development, sales training, product training, and there are other areas that there. So all these are associated with the training purposes. Okay, so basically it is all considered for the e-learning process, e-training or e-learning process. Okay, so the training in hazardous situations, how to give the training in the hazardous situations, because in the hazardous situations the trainer cannot work. Both the trainer and the trainee cannot work in a hazardous situation. The situation is hazardous. Okay, so how to get a feel of the hazardous situations? How some, say for example, something has to be done in a hazardous environment, and where you cannot send a person for the first time, and before sending the person for the first time, you must give the proper training to the person, how the training, how the reading should be taken from the machine, which is placed in a hazardous environment. It requires a lot of training, and this kind of training you can put it in a virtual form. So in a virtual form, you give a training for, say for example, 1 week training or 2 months training, 1 month training, and the person will become habituated with this kind of systems. Then if you send the persons to the real environment, then he can take the training properly, and he can also take the necessary safety measures. Also he can take the safety measures, so that hazards will not create any problem to the persons of the training. And this is like a learning. Okay, this is the learning pyramid, and this pyramid, I think probably all of us, we know that this kind of pyramid is there for the learning purposes, and there are 7 different type of learning styles are there. Okay, so one is the verbal one, visual, musical, auditory, physical, kinesthetic, logical, mathematical, okay, social, solitary, and the combinations of a few of these. And moreover, each student as a unique individual finds different types of these type of learning styles most useful to them. So it has been shown that from this point to this point, this is known as a passive teaching methods. Okay, so something like a listening. Okay, so listening, we generally get it from the lecture part. It's the listening part, and then reading, then watching. Okay, then in between there is a demonstration sessions, then watching of the listening, then hands-on sessions, and then do or teach method. That means you have to do something or you have to teach something. Okay, and in this method, what we can find, this is known as a cooperative type of learning method. This is known as a passive type of learning method. And if you see on the right hand side, this right hand side indicates the knowledge retention rate. And we can find that the knowledge retention rate at the top level, it is minimum, and the knowledge retention rate at the bottom level, if we go towards the bottom, it is maximum. Okay. So if it is only a lecture based kind of education, if it is a lecture based education, that means it is only for the listening. And in case of a listening, only whatever we listen, only we can retain or we can understand only 5% in the long run. Okay. And if we read something, this is of the order of 10%. Then audio visual form, it is a 20%. If it is a demonstration form, it's a 20% or 30%, something like a 30%. If it is a group discussions, it's a 50%. Practice by doing 75%. And the teach others, okay, or immediately you have to use whatever the knowledge you have gained. If you are considering this particular methodology, your retention rate is of the order of 90%. That's maximum retention rate. And there is a always we find that this kind of type of sessions. Okay, so this is an audio visual sessions, or if it is a kind of demonstration session. So in the case of a demonstration sessions, we can retain our knowledge of the order of 30% only. So it is better that you do some practice. Okay, you do some practice, or if it is possible, you take this your lesson for teaching to the others, or if it is possible, you can use this technology for some other applications. Okay, and if you consider this AR and the VR systems, we can consider this in the AR and the VR systems. What is the impact? So the impact is of the order of like a demonstration sessions. Okay, it is in between from the demonstration sessions to the teaching others, or it is a practice based. But here the practice based is only doing in the software side practice. It is not at the hardware involving. There is no involvement of the hardware in most of the cases. But still, it is a practice. Whatever the software has been built up, and yesterday also, Shaptok Bhattacharya has also built up some experiment, some sort of demonstrations applications. Also, he has developed that one. So if you can do this kind of exercises, okay, if you do some practice of this kind of exercises, that also it will give you the retention rate of your knowledge of the order of 75%. So unless and until we have a hardware systems, at least we can replace the hardware systems to some extent with the use of these virtual systems. So here we are in the educations going beyond the page. So if a picture is worth thousands of words, what would be an interactive picture would be? What about an entire interactive world where you can learn, play, and experiment in a safe environment? So you can see on the right hand side that there is a doctor, okay, so who is doing some kind of experimentations with the heart. So the heart is not a real heart, it is a virtual heart. Okay, so it is basically the graphics. And here you can see that he is using the graphics as if it is a real object. So just wearing a head mounted kind of display units, he can play with the virtual heart, and he can move deep into the virtual heart. Each and every components of the virtual heart or the actual heart, he or she can see through the eyes only. Okay, so this gives a better experience to the person. So we can say that this is an experiential learning. So the doctor is learning. Okay, but the doctor is learning, but this learning is experiential learning. He is experiencing from the learning process. So the students' engagement is not only a 21st century buzzword. So it is an important step in getting the students to take on the responsibility of their own learning. So the students has to take the responsibility of learning by themselves. Okay. Previously, we thought that whatever the informations or the knowledge we will provide to the students' knowledge is only restricted within that one. But no, when the knowledge is available to each and every student, okay, almost it is freely available. This knowledge is freely available to each and every student. Okay, so it is basically an ocean of knowledge. So with whatever you are teaching to the students knowledge is not restricted within that one. So there are different methods are there through which the students will get an opportunity to improve his or her learning process. So engaging the students is not a new issue, but thanks to the technology, there are now new ways to bring more engaging content to the students. And one example says through the AR to the VR. Okay, so we have to engage the students. Okay, unless and until we are able to engage the students, we have already found that if it is only a visual or only the listening only, okay, only 5% or the 10% of the knowledge will be retained only with the learner. So we have to engage to the students, and one of the ways by which nowadays we can engage the students when the students are working from home, or when the students are restricted in their home only. So in that case, we can use this AR and the VR technology, then probably we will be able to engage the students more and more involved in the problems, and their learning will be an excellent learning. So these new technologies are allowing the students to get inside the content and learn from a different perspectives, giving them a better understanding. So initial research is showing much improved engagement from the students' perspective, and the VR and the AR, it allows the teachers to guide the students through a virtual tool and bring to life abstract concept. Okay, so whenever we are showing something in this kind of writing form, okay, in the PPT form, so most of the cases, like say for example, if I explain what is hard and how it works, how it looks like on a slide, this kind of slide only, okay, so the students may not be able to understand it properly unless and until the students will have an access a complete hard. He can, unless and until he or she is able to see the 360 degree of the shape of the heart, and unless and until the students feel how the heart works. Okay, so what is the rhythm of the heart? So if the students is not able to feel that one, okay, so the learning process will remain as an incomplete one. So the Google Expeditions kits enable the students to go on the field trips without leaving the classrooms, and the expeditions explore various subjects including the history, science, the arts, and the natural world. Okay, so this is like is a field trip, like, okay, so the students, in most of the cases nowadays, the students are unable to go for any trip, in an industrial trip, or in, say for example, those students who are studying history, so they have to visit some historical places, and they are unable to right now because of this pandemic situation. They are unable to visit to these places physically. So at least in the AR and the VR systems, okay, they will help them, okay, to understand to actually give them the experience that if they were in the real environment, how the systems looks like. So here, and especially the VR, can deliver the realistic psychological and physical experiences through immersive real life situations in a safe environment. The technologies thus bring unlimited possibilities for teaching and the learning process. AR technology makes schooling more interactive, engaging and efficient. For instance, the AR applications, the students can observe a 3D galaxy on their tablet, or witness an extinct animals comes to the life. And the VR will help the students to see scientific breakthrough from the scientist perspectives, and even they can make the discoveries in a virtual lab themselves. So it means, say for example, a student is doing some sort of experimentations in a chemistry lab, and when the chemical reaction takes place, okay, so what should be the nature of the chemical reactions? Whether there will be a sound, generation of sound will be there, there will be, whether there is this development of smoke, is there any change in the color of the chemicals will take place. So everything they can see, they can visualize if they are using an AR and the VR systems. So the VR training simulators, they are used for the aviation purposes, for the automotive, constructions, energy, medical, military industries, as well as by the professionals, athletes. So their assisted solutions reduces the cost and boost the training retentions and performances. They also enable the students to interact in a new way with the other students and with their educators with the virtual classrooms. So everything means we know that how this now came to us, means from the knowledge perspective we came to know that this AR and the VR systems will definitely, it will help the educators as well as to the learners, okay, to learn the subjects more efficiently. So like a visualizations, then interest, safety, involvement in the process, full immersive and interactions. Okay, so these are basically the advantage of this mixed reality systems. That means the virtual reality as well as mixed reality means where the real and the virtual will combine together. So this is not only the visualizations, but also at the same time you can interact with the systems. Okay, with the software and the hardware we can interact with it, and you can be fully immersed with the environment, because whenever you are wearing a head-mounted display unit, so the rest of the things are you are not visible. You are not able to see the rest of the world. So you are only concentrating on what is coming in front of your eyes. So your involvement will be more and more. Your involvement will be at the higher level. Okay, so that you will have a better experiences. So here it shows that two persons are doing some kind of experimentations. Okay, and these experimentations is not a real experimentations. They are doing some sort of virtual experimentations. They are wearing these head-mounted display units, but as if the experiment they are doing the experimentations means experimental setup is in front of them. So whatever they are seeing in front of them means on their head-mounted display unit. Okay, so that has been shown over here. So this is basically a virtual experimentations. Now this is another one. The bottom one is the student certificate ceremony. Okay, so how the certificates are distributed in a convocations, like in a convocations we distribute this certificates to the students. So this is an environment. This is a virtual environment that has been created, and virtually the a person can call the name of the students by name of the students, and then the students may come one by one. They can come and they can take the certificates from the guest. Okay, so everything you can do it, everything you can make it in the virtual environment. So if somebody wants to get an exposure that how a convocations looks like, okay, so how the different events that happens in a convocations, he wants to explain it to some persons, okay, to the higher authority. Or if you have some sort of planning set that this year the convocations will be held in this particular manner, in this particular way, then how you will explain it to your superiors, okay, to the administrators. So if you can build up a virtual podium, okay, and if you have a virtual students, okay, if you can have a virtual guest, and you can make this total environment, you can make these total systems, and you can play it. That means the higher authority, they can wear this head-mounted display unit and they can observe these particular software tools. They can observe it, and from there they will be able to understand that for this particular year how the convocation is going to plan. Okay, so accordingly they can set the stage. Accordingly they can invite the persons, and accordingly also they can invite the students also. Everything they can control it. Virtually they can see it before a real convocation takes place. So that is the beauty of this virtual reality. Here this kind of training. So yesterday I was somebody has asked that how this can be used for military purposes. So the flight control purposes, before one gets a flight, okay, a real life experience. Before a real life experience, a person has to do some virtual experimentations. A person has to do. So here you can see that there is a virtual screens maybe there. So on the virtual screen there will be virtual knobs. So a person or the pilot can operate the virtual knobs, and they can see how the flight will behave. So it can be used for driving simulator, the flight simulator, the ship simulators, and for the tank simulator purposes. Tank maybe it's maybe for the ship. Okay, so for control of the ship, so it can be, captains can use or captain can control a ship, means they can learn how to control the ship with the help of these AR and the VR systems. Aerospace educations and the training purposes, it can also be used. I'm not going into the details of this, how it can be used. Okay. So there are certain applications areas that they are entertainment. Okay. For entertainment purposes, the children can also have a use of this AR and the VR systems. The doctors, yesterday I have shown. Okay. So medically, how it can be used. And there are like a 270 medical AR and the VR companies are there. So this is very good news that there are AR VR companies who are dedicated their business for the AR and the VR application side for medical field. And there are 20 clinical sectors are there. 20 clinical sectors are there where this AR and the VR technology can be useful. Okay, so like a cognitive rehabilitation purposes, exercise purposes, okay, and disability solutions. How a disabled persons can be trained. Okay, so whenever some sort of devices is provided to a disability person or physically challenged people, so how they will use it and how they can improve the performance of the assistive devices. Okay, this kind of assistive devices that will be provided them. So what should be the use method? Okay, so what should be the technique? So all these they can learn it before actually they started wearing all these kind of assistive devices. So this is a very important area. So disability training purposes, disability solutions purposes, it can be used. Another one is the patient education purposes. Nowadays, most of the cases where, say for example, the doctors after doing the operations, okay, they don't want to keep the patients in hospital, because if they keep the patient in the hospital, then naturally the cost will be increased, and most of the cases the patient party may not have that much of financial capability to bear all these costs. Okay, so that's why the doctors generally they prefer that the patients can be taken home, but at the same time they want that the patient party should learn how the patient should be given care. That is very, very important. Patient caring is very, very important. Okay, so there are AR and the VR systems are there, which is given to the patient party. So the patient party can learn that how the patient should be taken care through these AR and the VR systems. Okay, so before that they take the patient to their home, they must have sufficient knowledge and understanding that this particular patient, say for example, a patient has a heart problems, he went for open heart surgery, how the patient should be taken care, so that everything has been, doctor has been explained, doctor has been shown graphically also. Okay, he has explained it graphically, everything has been recorded in a CAD model based, and now the patient party has to listen all this, has to understand it, wearing this head mounted type of display unit, and they can also do certain experimentations also they can do. Okay, so patient party will say, for example, the doctor has always provided that the patient must be always in the lying conditions. Okay, so that the patient should not be in a sitting conditions. Now the patient party should understand it, and the patient party have an inquiry or queries. Okay, inquisitive minds, and they can see that what will happen if the patient is in a sitting posture. If the patient sits, then what happened? So these experimentations also the patient party can do it with the help of these AR and the VR systems. So that is the beauty of this kind of AR and the VR systems. Okay, I'm not going through all this how it can be used, and yesterday also I have explained this particular slides. Okay, I have shown some sort of video also, and from there I think you understood that how AR and the VR concepts. Okay, from that how it can be used, and how the patients, here you can see that the patient need not to explain his or her problem to a real caregivers. Okay, but at the same time he is getting all sorts of supports, advice from the caregivers. This is like a flight controls. Okay, and this is another one is the military persons, training of the military persons. So the exposure based treatments can be educated in the safety and the comfort of an office settings environment. Effective tools for treating a variety of clinical problems, in particular anxiety and addictive disorders. Fully immersive environments with include the use of a head-mounted type of display, 3D sound, tactile simulations via shaking platforms, then olfactory simulations. Okay, so these are used for this post-treatment stress disorder purposes. This can be used, right? Okay, another applications that here in the VR systems application is for pain distractions method. This has been observed by the doctors that whenever there is a pain, okay, like here in this figure, it is shown like a child has a pain, okay, and if the child is wearing a head-mounted display unit, or if he or she is observing a virtual reality environment, AR/VR systems, okay, wearing a AR/VR systems, okay. So at that time, it has been found that the patient, okay, so he or she will forget about the pain part, the real pain part, okay. So you can see that here in the VR systems can also be used as a pain therapy, as one of the pain therapy method by which, okay, so a patient will forget about his or her pain if at that time, if he or she is wearing a head-mounted display unit, and he basically, what will happen here, that the patient is immersely involved with the situations, so he does not have the time to think about his or her pain. So naturally, he or she will not feel this pain. So this is very important one. For agricultural purposes also, this means one can use this virtual reality environment. Okay, virtual reality systems, one can use it. So on the left hand side, you can see the real robot system. On the right hand side, there is a virtual robot. And in the real robot system, in the left hand side, real robot system, say for there is a tree and there are fruit subjects. Now, how the robot will pick up the fruits? Okay, so one has to do the experimentations. But if you want to see that how virtually the robot will do, how virtually the robot will pick up the fruits, so you can have a virtual system and you can observe it through your head-mounted type of display units. I have a small robot with me. Okay, so I think that maybe you have an exposure. You just a minute. Okay, so this is a small robot. I have a very small robot, and this is known as a KUKA type of robots. Okay, and generally, whenever we teach this robotic subject, generally we show it to the students. And as I understand that as you are a mechanical engineer, most probably all of you have seen a robot, at least not in the real form, but in case of a video, you have already have an exposures. Maybe you have a subject, you are teaching the subjects of robotics, CAD/CAM robotics subject to the students also. Only for those who does not have the knowledge of this robotics. So only for them I'm showing it. And here you can see that this is a toy one, and this toy can be moved. I can move the robots like that. I can move the robots. Okay. So the robot is moving with respect to the base, and this is the first arm movement. This is the second arm movement. This can move like that. Okay. And this is known as a gripper part. Okay. And this gripper part, or this is the gripper part, and which can move in different directions. So it may have a 3 degrees of freedom systems, or 4 degree, 5 degree, or maximum 6 degrees of freedom systems. Okay, and this is known as a Puma type of configurations, or sometimes it is also known as a articulated type. So if there is a fruit is there, okay, so the robot has to pick up the fruit. So you can do the experiments. If you have a real robots, you can move the real robots to these particular positions, and then you can pick up the fruits and then bring it back to its original positions. You can take it back in that way. But the question is, those who does not have the real robots, if I don't have these systems, I cannot show you that how this robot will work. But if I have a virtual systems, I can do the experimentations for thousands and thousands of times, and I can show that how a virtual robot will pick up the objects, pick up the fruits from the virtual objects also. So for training purposes, it can be shown, it can be used for the training purposes, so that those who will use a robot, actual robots for fruit picking purposes, okay, once they are satisfied with their training, then they can be given the real systems, and they can start with the real devices. They can start. So this way they can do. I'm not going into the details. And thing is that AR and the VR system is also used for the industry 4.0, and basically one of the components of this industry 4.0 is AR and the VR systems. Okay, and now we can see that industry 1.0, then industry 2.0, industry 3.0. So how we are moving it? Okay, from a manual systems to a mechanized to an automation systems, we are moving towards more and more. Okay, and now whatever the industry 4.0 exists today in the industry, okay, most of the cases there is basically the digitizations of our manufacturing process or digitizations of the industry, as well as the use of these AR and the VR systems and the IoT based data acquisition systems. Okay, so these two are the main components which has been added, and which and because of that there is a lot of improvement in the concept of industry 4.0. I'm not going into these discussions about this industry 4.0. So like a complex assembly, maintenance, expert systems, training, factory training, inspection purposes, all this can be used. Here it shows that how these AR and the VR systems can be used for the training purposes, for the industrial training purposes, it can also be used. And you can see that there is an object, okay, and this is not a real object, this is a virtual object. And whenever the person is wearing a head-mounted display unit, he can see this virtual, maybe a pump motor setup, a simple pump motor setup. And a student has to get some, or a person wants to get more and more exposure to the experiences about this pump motor setup. So for that, he or she did not to purchase a pump motor systems. So I can have a virtual object, so I can have a virtual model, and if I see through this head-mounted display unit, it becomes almost, it looks like a real systems. I'm going first. I will. Okay. There is shortage of time. Otherwise, we will not be able to do the demonstration sessions, and which I feel that is more interesting. Okay, so this theory part, definitely I will share these presentations with all of you, so that you can also see these presentations. You can go through all these presentation slides. This is another applications of this VR, and this is known as a haptic device. Okay, so in case of an AR and the VR system, when we are just using our eyes, so visually we can see the information. Okay, and whenever we are putting some sort of headphones, so we can also listen some things. But what about the feeling? Okay, I must want to feel. I must want to get some sort of feeling, or whenever the doctor, say for example, the doctors are doing some sort of surgery operation in a virtual form, not in the real form. Okay, in a virtual form. If the doctors are doing some experimentations or operations on a real patients, the doctor has a feel, they can get the feel that whenever some medical device is entered into the patient's body, what is the resistive force? And the doctor will feel that resistive force in their hands. They can feel it in their hands. But what about the virtual form? Whenever I'm doing the experimentations in the form of a virtual form, I will not get the feel unless and until I have some sort of devices. So for that purposes, you can see on the left hand side, the person is wearing some sort of devices, and this device is known as a haptic device. So whenever some hard object is gripped by the doctors, okay, virtual form, hard object is picked up by the doctors, then the person will apply some sort of force for the gripping of the person, gripping of the object. And if the object is very hard, immediately the resistive force will be felt by the doctors in their fingers. So from there, the doctor also virtually can get a feel that whenever an object of a hard object will be picked up, it will be gripped. At that time, there will be a tremendous amount of resistive force will be faced by the operations of the fingers. So if you want to close your finger, you will not be able to do it. You will not be able to do it. So that will give you a virtual feeling to the doctors, okay, that they are trying to hold an object which is very hard, and practically speaking, whenever you are holding the object, a hard object, you have to apply more and more pressure, you have to apply it. So some kind of kinesthetic type of feeling will be experienced by the doctors. Now I have a small setup with me, and this is known as a haptic device. This is known as a haptic device. Okay, and this haptic device, Shapta, can you help me that how I can make the background clear type? Okay, so the screen is visible, the PPT is visible.
Yes, sir.
Okay, and the hardware is visible. I'm not able to see.
Yes, 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 sir. Yes, sir.
I'm not able. Okay, okay. So this is known as a haptic device. Okay, and if you see the previous one, okay. So previously I have like this kind of systems. I have already shown it. Okay. So look wise, if you see these systems also look wise, it looks like a robotic systems, like a robot type. Okay. Now the point is that this is not a robot, but its purpose is something different. Okay, so I can this is like a pen. Okay, so with the help of this pen, I can move it. I can move it to the different location. I am just moving it. Okay, you can see that I'm just without any force. Okay, almost with a zero force, like I can move it like that. Now this is known as a haptics device, and what I can do, I can make an virtual environment. I can make it. Okay. So virtually, I can say that I can make a virtual room, and in the room there are like inside the room there are like 4 walls are there. Okay, there are 4 walls are there in the room. Now, if I move my pointer, if I have some sort of object, and if I wants to move the object towards the wall, if I wants to move it, then initially I just move my cursor or the pointer. Okay, the object will move. And now when the object will come in touch with the wall, because there is a wall, and this wall is a virtual wall. But when the virtual object is in contact with the virtual world, it means that if the wall is a very hard object, and if the object that is moved, this is also a very hard object, then what will happen? 2 hard objects will be there. So in that situations, if I try to move my cursor or the pointers, okay, the object will not move. So at that time, what will happen? I will feel excessive force in my hand. So I will not be able to move it further. Even if I am trying to move it further in the right hand side direction, I will not be able to do it. And virtually, I can do these experimentations. Virtually, everything is virtual. Only this is acting as an input device. I'm giving some kind of input commands to the AR/VR systems, and virtually everything is happening virtually in a computer screen. But whenever the object is in touch with the virtual object is in touch with the virtual world, immediately resistive force will take place, will occur, will generate, and that resistive force will not allow me to move the object more and more towards the wall. Okay, so this kind of feel I can get it with the help of this haptic devices. Okay. I'm not showing this way. Okay, and this is what we can see, that there is the real objects. Okay, so there are real robots are there. On the real robots, there are certain virtual parts are there, and the real robot and the virtual robots, they are coinciding each one over. This is an overlap situations, and this is known as an augmented reality. So there is a real environment is there. You can see that the person is in front of a environment where there is a real robots, and on the real robots, the virtual robot is superimposed. Okay, so here in this particular figure, you were saying this is a virtual object, this is a virtual robot, virtual cat model. And now, if you see that how the virtual systems will work, so you just put your goggles over here, and you can see that the movement of the virtual robots. I'm not going through this. A lot of things are there. Okay, and this is our laboratory, and some of the works that we work. Okay, so that has been showed over here is a kind of poster type of work. We generally prefer to work in a hardware platform, so we develop a lot of mechatronics, robotics related product developments. We generally develop it, and whatever the product that you are seeing over here, so everything has been built up by us. Okay, and okay, so I will play I will play some video. That is an interesting video. Okay, so let me play with this one. Just a minute.
Virtual reality and augmented reality. They kind of sound like something you need a drug counselor to get through, don't they? But in fact, they're the hottest two technologies going these days. Let's learn about them so we can compare and contrast what each of them does, so they wow you instead of overwhelm you. Augmented reality is when you look at the real world.
Is it visible?
Virtual reality and augmented
Yes,
reality.
yes, sir. Yes,
Kind
sir.
of sound like something you need a drug counselor to get through, don't they? But in fact, they're the hottest two technologies going these days. Let's learn about them so we can compare and contrast what each of them does, so they wow you instead of overwhelm you. Augmented reality is when you look at the real world, but it's augmented with additional information or graphics in your view. Now, key to this AR concept is that the things are indexed to a location. That means they occupy a relevant place in your view, as opposed to moving with your gaze as you turn your head. And in many cases, you can interact with those visuals that are augmenting your view. AR can be had via a phone and one of the many AR apps out there. Or for higher performance, you use dedicated AR glasses. Know that AR is increasingly being referred to these days as MR, mixed reality. It's part marketing term and part acknowledgement of AR's ability to augment the real world while also bringing in unreal elements. Glasses that augment your view without being indexed to a location and space are better referred to as connected head-up displays. Now, Google Glass was the infamous standard bearer of that sector, but more recently, Vuzix has shown their pending Blade, an impressive set of head-mounted displays that include integration of Amazon Alexa to help you drive what's displayed via voice. Virtual reality is when the world you're standing in is replaced with a virtual one. With some of these, everything you see and everything you hear is replaced with something computer generated. Now, the world that takes you to can be very naturalistic, actually, or extremely synthetic and fantastic. VR, you're surrounded in 360 degrees, and the space is three-dimensional. Now, in its most ambitious forms, VR places are also navigable, as you can move through them and use your hands to manipulate things within them. VR can be done as simply as sticking your phone in a literally cardboard head mount or a little more upgraded plastic holder. But the attention these days is mostly on real deal head mounted displays. Until recently, these were quite cumbersome and always tethered to either a game console or a high performance PC. But more recent versions acknowledge that tethering is going to be a non-starter for a lot of users. And instead, the new headsets build the electronics into themselves or maybe into a small companion processor you wear on your belt for a pseudo cordless experience. The bottom line on AR or VR is that you really have to experience it to understand it and appreciate it. It's very hard to read an article, look at a video like this, and understand the impact of these. They aren't like a lot of other technologies. The good news is you've got plenty of time. Both of these are pretty green and have a long way to go before they hopefully merge into a pretty smooth continuum of abilities. Whereas right now, it can be a little hard for the average user to knit them together, let alone find a use case that makes sense to them.
Okay. And let me share another one or two. Here I'm playing it one more. Is a kind of is visible, I think.
Yes, sir.
Yeah. So this is a like a is a virtual. You can see that there are a person is working in a real form. Okay. So just he is moving the hands, two hands, left and the right hands movement is taking place. And actually, he is doing some sort of practicing some sort of assembly operations. Okay. And the assembly operation, he can see it on the screens, means through the graphics. It has been shown that how the assembly operations is taking place. So if the person is wearing a head-mounted display unit, so he or she is seeing whatever the CAD simulations is going on. And here you can see the person is just picking up the different parts or different components. And for that purposes, there are two pointers are there, locators are there. So one is the red color one, another is the green color one. Okay, so they are basically attached to some objects. So whenever a particular one is attached or particular one is picked up, pointer is picked up, the particular components will be picked up, and you can see that how the assembly operation is taking place. He's just doing some sort of hands movement is doing. Okay, and there is a camera which is placed on the top. So the camera is practically grabbing the movement of the hands movements is grabbed, and that hand movement is now connected. That means there is a software tools to which analyze the hand movements, and accordingly the virtual objects or the components, they are connected with the hands movements. Okay, and you have to teach that what does it mean, like a picking operations, placing operations, how it is connected with the virtual object, that you have to teach it first. Okay, and then only you can do these experimentations. Virtual, we were just learning the different assembly process or disassembly process. Okay, so virtually we are doing the experimentations without having any hardware components before you. Okay, and most of the cases there are some critical assembly operations that yes. Okay, say for example the satellite operations, satellite build up of the satellite assembly operations. Okay, so you have to do the assembly operations only once. You will get an opportunity to assemble all the components. Okay, very precise components, scientific components, very costly components only once. So if you make a mistake, then that particular components you have to throw away. So in that situations, this AR and VR based maintenance training, assembly training, this is very, very important. I will show just a minute. This is the last one.
Digitalization is one of the most important.
I will connect it.
Digitalization is one of the most important driving forces for technological trends and new developments. The networking of machines and systems, as well as gathering in Digitalization is one of the most important driving forces for technological trends and new developments. The networking of machines and systems, as well as gathering information on basic and status data of devices, forms the basis for that. The added value this data provides is demonstrated in Phoenix Contact's in-house tool shop. Thanks to the comprehensive networking of all machines and tools in production, setup times of injection molding systems can be reduced significantly. Every workspace offers access to tool data and databases with animations and 3D models on every tool. In addition, toolmakers can also use augmented reality systems that facilitate processes and reduce the error rate. That's how the complex injection molding tools can be classified immediately.
So here you can see that the person is roaming from one point to the another point, okay, in the industry. And then this is the background is a real one. The person is really he is working through the shop floor. But suddenly he thought that he wants to get some sort of information about the machines. What kind of machines it is, what it is doing, what is the temperature, okay, what type of operations it is doing, whether the machine is working or not, whether this machine is under maintenance or not. So all this kind of information, say for example, the person is interested to know. And what he can do whenever he is roaming, he will come in front of the machines and he will just click. Okay, so he will just make a click, he will make some sort of a hand movement will take place. So immediately the informations associated with that particular machines will be visible to the head mounted display units. So everything that means in the head mounted display unit, he is seeing what really he has to see. So everything in the real form, he is seeing it. But along with that, he is getting some more information about a particular machines or a particular environment. And this is coming in the form of a digital. And if the machine is like a real time of systems, real time, and if in the say for example the machine has an engine and the engine temperature is continuously changing, so immediately if the machines is connected in the digital form, okay, with the virtual reality systems, so on the virtual screen monitor the head mounted display unit, he will see the temperature and which will continuously it is varying. It is not like a static one, it becomes like a dynamic one. So if the temperature in the real environment, if it is changing, then the information which is coming in the yellow form, that will also continuously, it will change in the real form, it will change. And the person who have a real experience of the exposures or the knowledge or the informations regarding the temperature of the particular machine. So that is basically the beauty of this augmented reality system. So as we know, this augmented reality, so real systems and this kind of information, these informations are basically, it is in the form of digital informations. So you have added the digital informations on the real systems and you have augmented or you have increased the value of the particular machines or a particular product or the process or whatever maybe you call it. So let's play the next.
Sprue runners, heating and cooling circuits, as well as the optimum tool temperature are indicated, precisely where they are located. Facility management in Bad Pyrmont also uses AR technology today. The required data is provided by Analytics, the Phoenix Contact building management system. Thanks to the intelligent networking of the entire building technology, every user has access to the right information at the right time. External maintenance personnel is led independently and informed about everything that is important in the event of a maintenance work. Controlled safety instructions are given directly on the spot, immediately before use. With the high level of data depth, Analytics creates transparency. Augmented reality technology makes it possible to experience this transparency. If you are also interested in experiencing augmented reality with regard to Industry 4.0 and building technology, come and visit us at one of our sites. Together with you, we develop your own digitalization strategy.
Okay. So with this, I conclude. So now I request Saptak Bhattacharya to demonstrate these AR and the VR systems.
Thank you, sir. So let me start with today's presentation. So yesterday we discussed about marker-based augmented reality application development. Now we have learned something about the target image acquisition, marker recognition, Vuforia, how to create an account in Vuforia, then license configuration and target configuration in Vuforia, how we can upload the target image in Vuforia and train the computer vision algorithm in Vuforia and download it as an Unity extension package. We have also seen how to create a project in Unity 3D and how to interface the downloaded models as well as the license from Vuforia in Unity 3D. As well as we have seen how to create a game object, a simple game object like cube, and how to develop the first AR application for this project. So from what we have discussed yesterday, this is what we have resulted this video, that when in real time this AR application is played, the computer is running the AR application, so the computer superimposes the virtual object on the real world object, which we term it as augmented reality, because we are augmenting a virtual world with the real world. Now, we also discussed, and I have also shown you yesterday, that we can animate the augmented reality object or the virtual object. So how to do that? Now, how to create the game object animation, I will show you. Now, there will be a similar procedure to create the game object. I have created the game object, the box I have created, and there is an AR camera. The cube is the child object of the image target, and the AR camera is visualizing the image target. Now this is just like what I have shown you. Now how to animate this cube? So to animate the cube, what we have to do is we have to control the behavior of the cube. Now we can control the behavior of any game object in Unity 3D through attached scripts. That means with the help of programming, we can control the behavior of virtual objects. So we have to attach a programming script in Unity with the game object. Now till now there is no script attached with it. So if we want to attach the script with the game object, what we have to do is we have to come to this section known as add component. Now when we will click on this add component. So I have selected the cube and this is add component. So I'm just reorienting the cube first in the rotation part, so that the rotation can be understood quite well. Then we will click on this add component once the reorientation part is complete. So I have oriented in a diagonal manner, and then when I click on this add component option in Unity 3D, then the options will appear like mesh, FX, physics. So here we have to scroll down and we have to go to new script. Now, what is the programming language in Unity 3D? So in Unity 3D, the programming language is C# or C or hash sign. So C# is the programming language in Unity 3D. If we want to control the behavior of any game object, if we want to animate it or whatever we want to do, we have to write the programming in C#. So I am opening a new script and I will write a C# code in order to control the behavior of the game object. So I'm just naming the script as rotate game object. This will be the name of the script that will be attached to the cube, because cube is the game object over here. So whatever will be written in the rotate game object script will govern or govern the behavior or control the behavior of the cube. So once the script is selected, where we will find the script? The script will be under the assets folder. So where is the assets folder? So we have to go to the assets folder and we will see the rotate game object script is there. So if we will double click on it, the script may open either by using two software. One is Unity. When Unity gets installed, it asks for its own programming editor software, that is MonoDevelop, or if you are having Visual Studio. If you are having Visual Studio installed in your computer, then you can also open this file using Visual Studio. If you don't have Visual Studio, then Unity will be opening this file by its default MonoDevelop. So so when I double click it, the Unity script opens in MonoDevelop. So this is the MonoDevelop window, which it looks like. So it is still loading. Now the rotate game object .cs, the script has came. So by default, Unity has placed some libraries like system.collections and then system.collections generic and Unity engine. These are the default libraries that is required by Unity to operate any game object. So we don't need to write them. Unity by default provides these libraries. So since we have named the script as rotate game object, so a class has been automatically assigned to the rotate game object. Now inside this rotate game object class, we will write our script and then we will call this class. So basically we are dealing with objects and classes, because here also the concept of object-oriented programming is there. So inside the class rotate game object, we are defining a variable as rotation rate. This is basically, we are defining at what speed the rotation will take place. So if I make it 20, 30, 40, the speed of rotation will increase consequently. So I am defining a variable rotation rate at 10f. F is for float. So I'm defining it for 10 hertz, 10 cycles per second. So that's why I am giving it as 10. Then comes as void start. Here in the start section, so the programming part consists of two sections. One is void start, one is void update. In the void start section, we will write the initialization parameters. And in the update section, we will write the code which will be iterated continuously till the time the program is running. So in the void start section, we don't need to initialize anything here. So we will just try to print when the animation is started. So that is why the command is debug.log game object animation started. So whenever the AR object is detected, automatically this will be printed in the console that game object animation is started. Next, in the update section, to rotate the game object, to rotate the cube, we will write the command transform.rotate. So this transform.rotate is the command to rotate any game object with which it is attached to. So here we have to write transform.rotate. Now we have to specify at which direction we want to provide the rotation, right, left, up, or down. So I want to rotate the game object in downward direction. So that is why I am writing vector 3 down. So if you type vector3.u, it will give you up. Vector3.l, it will automatically tell you that is left. So it is just showing what are the available commands in C# for Unity 3D. I will be assigning it down. So I'm writing vector3.down. Now why vector 3? Vector 3 means rotate the game object in 3D. So that is why it is vector 3 downward direction. So vector 3.down. Then we have to specify the rotation rate. So whatever rotation rate we have given, we have to multiply it with the time unit of Unity 3D. So that is why I'm writing here rotation rate into time dot delta time. So time dot delta time. So this is basically time in seconds it to complete to the last frame. So this is a timer in Unity 3D. We are multiplying the rotation rate with the timer, and this is how we are getting at what rate the game object will be rotated. So vector 3 dot transform dot rotate, vector 3 dot down, rotation rate into time dot delta time. So this is the command for rotating any game object in downward direction in 3D. So this is the single line that we will need to rotate the game object. Once that is done, we will just save the file and we will close the file. So once the file is saved, we will close the file. So the rotate game object script is already attached to the game object cube. Now, if we press play, let us see whether we are getting the animation or not. So this is for testing. Now, if I in real time, I show the AR object. So we see the rotation is happening in downward direction. Till the time the image is visible, thus AR object will be superimposed. Now next is, I have already told you that apart from game objects, this cube, we can also create 3D models in 3D design softwares like SolidWorks, Solid Edge, or Autodesk Fusion 360. So we can create 3D models and we can import 3D models in Unity 3D. And we can actually use those models as game objects also. So not only we can use the Unity game objects provided by Unity, standard game objects. We can also use our customized or designed game objects just by importing those CAD files. So we can also use Blender and then we can import them. Now, not only 3D models, but also we can superimpose video files, which is necessary for Industry 4.0. So whenever the marker is detected, a video automatically starts playing. So we can superimpose media files in AR also. Now how to do that? Let me show you. So first what we have to do is, so cube is our game object. I will be deleting the cube because we will be placing the media as game object. Now to place media, we will select the view area, and then the image is already there. So image target is already there. Now in 3D object, we will select plane. To place media, we will select plane. Because why we are selecting plane? Because the video will be played in a plane. So any media file needs to be played in a game object, which is a plane over here. So plane will be the child of the image target in this application. So we have selected a plane, but we have not uploaded any video. So it's a white plane. So what I am doing over here is I am reshaping or resizing the plane just with the size of the marker. And I will place this plane perpendicular to the image target. So when the image target is detected, the video will be played perpendicularly. So we can change the position and orientation of the plane as well as the scale of the plane from this transform section of position, rotation, and scale. Or we have these buttons like move, then rotate, then this is for scale. So we can use these buttons also for scaling, changing the position, or rotating. Now I am trying to place the plane perpendicular to the image target. Now once the plane is placed perpendicular to the image target, the next part is to make the plane as a child of the image target. So whatever behavior the image target will undergo, the plane will undergo the same behavior, just like as I have shown yesterday. So what we have to do, we have to click on plane, and then we have to drag it and place it on image target, and automatically the plane will be the child of the image target. Now in this plane, we have to add the video we want to play. So first what we have to do is we have to select the video and place the video into the Unity assets folder. This is the video I want to play when the AR marker is detected. This is VR robotics simulator spot welding. So I will just select it, I will drag it, I will place it under the assets folder of this particular project. So once the video is placed, next what we have to do, we have to add a video player with the plane so that the video can be played in the plane. So what I will do, I will select plane, and then again I will go scroll down, I will go to add component, and I will select video player. So if I go down and I select add component and then video and then video player. Now here an option will come in video player. So I have selected the plane and the video player. In the video player, the video clip is none. So what I will do is I will just click in the right side of the symbol, which will give me the option to select the particular video that I want to play. So if I go and if I click on this symbol, this circle, and inside having a dot, then this will give me the option for the video clip. So here we need to select the VR robotics spot simulator spot welding. So I have selected which video clip needs to be played. So the video clip, the video has already been selected and everything has been done. Now we have to click play to test. Now the video starts playing. So not only video, we can also use sounds to be played. So I think there is a problem that sound is not getting played. Now, this was all about how we can create augmented reality applications with game objects, as well as we can animate the game objects, as well as we can place video files or media files in Unity 3D, and we can create an AR application. But not only that, as I have told you, let me show you another example where I'll be importing a CAD model. This. I'm having some trouble to play the media. Let me move to the second option. I will come back to the video afterwards. Okay, now it is coming. So in this screen, what I'm showing here, whenever, am I audible? Hello, I am audible?
Yes, sir.
Okay. So in this screen, you can see the model of this robot. So this CAD model, which I have made in the Autodesk Fusion 360. Now I have made this CAD model of this robot, and I have imported this CAD model in Unity 3D, and I'm using it as a virtual object. Now, through this application, what you will get to understand is that we can interact with the AR objects as well. So here we will control the movement of this AR robot by the help of these sliders which are here. So these sliders are there to control the angles of the robot, as well as what I have done over here is I have implemented the inverse kinematics of this robot movement. So for point-to-point movement, when I give the robot 5 points, so for this point-to-point planning, path planning, the robot by using its own inverse kinematics will actually follow a trajectory which will contain all the points, all the 5 points I have given. So we can implement inverse kinematics, we can implement mathematical calculations, formulas, as well as we can interact the AR model. So this robot, I have made the robot over here, and I have used this marker for tracking. So whenever this marker is detected, the AR model of the robot is shown as with this some user interfaces like sliders and buttons, and also input boxes. So whenever I'm placing the file, the image or the image of the copy, the robot model is being shown. Now I can change the rotation of each link with the help of the sliders. Suppose if I change the θ1, so besides θ1, θ2, and θ3, the robot angles are being shown. So if I change the θ1, θ2, and θ3, so θ1 is for base, θ3 is for this joint, and θ3 is for this joint. So there are 3 joint angles, one for base, one is for 3, one is for this, and one is for this. So when I'm changing θ3, we can see how the joint angle of θ1 is varying when I'm changing θ1. And if I'm changing θ2, this joint angle varies. So I'm interacting the robot with the help of sliders. This is a very good example. If you want to teach something, if you want to make mathematical models of devices and you want to teach how the devices perform, then you can easily show them with this application. So this is θ1, then θ2, this is for θ3. Now, next what I will do is I will give 5 positions that I have told you. So the robot, I will specify 5 positions of the robot, and the robot will track those 5 positions by using the inverse kinematics. So suppose I am saving this position as position 1. So what I have to do, I have placed the robot, I have to place the robot in a certain position, and I have to click the save position button. This is also made in Unity 3D, as you can see. So this is the first position. Then I will change the orientation of the robot a little bit. I will save it as a second position. So let me consider this one as the second position. So then again, I click on save position. This is the third position. So I'm only specifying the points, but I'm not specifying any trajectory. The robot, by using its own kinematics, inverse kinematics, will follow generate the trajectory and will follow these 5 positions. So I have placed the robot in 5 different positions, and the time duration I have specified 3. So that means the robot will track these 5 positions in 3 seconds. And now if I go to save, now we can see the robot is actually automatically tracking the 5 positions by using its own inverse kinematics. So let us see it again. And through this example, what we can understand is we can interact with the help of sliders, we can have buttons, we can also have input boxes with which we can specify inputs which the robots will follow. Here is move to XYZ option, but you can specify a specific 3D position and the robot will immediately go to that specific position. So here robotics, virtual reality, I'm integrating robotics with virtual reality and augmented reality, and that is what is making this possible. Okay. So now what I will be showing you is how to control the movement or the behavior of a game object with the help of, from the input of real world sensors. So earlier we were controlling with the help of programming scripts. We are animating the behavior of the game object. Here from the sensor data, we will be controlling the orientation of a game object. Now this is pretty applicable for movies also, VFX effects. So when the movie is basically prepared, so the actors and actresses wearing sensors, they actually perform the acting, perform different stunts, and those sensor data is used to control the characters of the movie. So not only in case of movie, but in case of military training, in case of hand-to-hand combat training, in defense, specifically for doctors, for training purposes, surgical training purposes, surgery training. So in lot of applications, this type of concept is being implemented. So I will show you a very simple application where we will control the orientation of a VR object with the help of accelerometer data. Now, for this purpose, I have used a data acquisition board which is quite popular and which is known as Arduino Uno. So the Arduino Uno is a Atmega 328P. It is having the Atmega 328P microcontroller. So this is the heart of the microcontroller board. And along with that, so it is having digital pins, digital IO pins, where we can give digital inputs or we can interface digital sensors, or we can use these pins as output pins where we can connect digital outputs like LEDs, or we can turn on or turn off a motor also. So these digital IO pins can be used in such purposes. Similar to it, the board also contains some analog ports. Now, in case of analog ports, we can interface analog sensors. So in these analog ports, there are ADCs interfaced with the microcontroller output. So that is why we can take these ports as analog input, or we can use this port. So this A0 to A5. So there is 6 analog inputs, and there are 14 digital input output pins. Then we can interface other devices like Bluetooth devices or Wi-Fi devices with the serial pins. Now the advantages of this Arduino Uno is the programming is very, very easy. It follows a C-like structure, but it's a pseudo C. The programming part is very easy, and there is huge support for programming. It is very easy to learn. Next is it is having analog input and PWM output. So there are PWM pins which can be used to control servo motors. Also, the board is low cost, but the limitations of this Arduino Uno board is it is having very low memory. Board is noisy. The processor speed is not much higher. Maybe the clock speed of this microcontroller is 16 Hz. There are also 8 Hz versions. That means the maximum processing speed will be either 8 megahertz, so 16 megahertz. Half of it is 8 megahertz or 4 megahertz. So not much higher processing speed. Not suitable for machine learning, deep learning applications. No built-in Wi-Fi or Bluetooth. You have to interface Bluetooth or Wi-Fi devices in order to make it wireless, but it can be used as a low-cost data acquisition device with easy coding. So I will be using this Arduino Uno as a data acquisition device, with which I will interface the accelerometer sensor, and the Arduino Uno will take the sensor data and will send the data to the computer, which is running the AR application. So which I have developed in Unity 3D. So there is a communication between, serial communication between Arduino Uno and the computer running Unity 3D. Now, this is the Arduino Ide, or the interactive development environment, where the programming is done. Now, each of the program of Arduino Uno again consists of two steps, two different segments. So what are they? One is void setup, where we write all the initialization parameters, and the other thing is void loop, where we write the instructions which will be iterated continuously till that program is running or the board is powered on. So we have to choose the coding instructions very cautiously, which one to place in initialization portion and which one to place in iterative portion. Now this is the accelerometer module Adxl 335, which I will be using to measure the acceleration force. Now I will first measure the acceleration force, the acceleration along x-axis, y-axis and z-axis. So this is a 3-axis accelerometer. So there is x-axis, y-axis and z-axis accelerometer will be sensed by this accelerometer and will be sent to the Arduino Uno. Now the Adxl 335 module gives a complete 3-axis acceleration measurement. This module measures acceleration in the range of plus minus 3g in x, y and z axis, and the output signals of this module are analog voltages that are proportional to acceleration. That means when the acceleration increases, the analog voltage also increases, analog output also increases, and vice versa. The output of this Adxl 335 is generally in between 0 to 5 volts. So we have to interface this Adxl 335 sensor with Arduino Uno in one of the analog input ports. So the sensor will be connected with the analog input port of Arduino Uno, because the Arduino Uno will be taking the sensor data. Now the Adxl 335 module contains a polysilicon surface micro machine sensor and signal conditioning circuitry. Now how this accelerometer functions? The working mechanism behind this accelerometer is basically there are some fixed plate and there is a moving plate. Now in between the fixed plate and moving plate, the capacitance is measured. Now during acceleration, the moving plate moves in a particular direction by changing the capacitance between the plates. And when the capacitance changes, the output voltage of the sensor also changes. Now the acceleration deflects the moving mass and unbalances the differential capacitor, which results in a sensor output voltage amplitude, which is proportional to acceleration. Now phase sensitive demodulation techniques are then used to determine the magnitude and direction of acceleration. So we get the magnitude as well as the direction of acceleration from this Adxl 335 accelerometer module in 3 axes. Now this Adxl 335 module consists of 5 pins. One is VCC and one is ground. So these are for biasing or supplying voltage or for operating the sensor. VCC will be connected to plus 5 volt of Arduino, because this sensor functions in plus 5 volt, operating voltage of 5 volt DC. So VCC will be connected to plus 5 volt. Ground will be connected to ground pin of Arduino Uno, and the X out, Y out, and Z out. These 3 pins will be connected to 3 analog inputs of Arduino Uno. Now, when we are taking the accelerometer values, the acceleration along x-axis, y-axis, and z-axis through the analog input ports of Arduino Uno, but we want to orient the game object, or we want to change the orientation of the game object based on the acceleration sensor values. So that means we have to calculate the orientation angle from the acceleration values. And for calculation of the orientation angle from the acceleration values, for calculation of the angle of rotation, so that is for x-axis roll, for y-axis pitch, and for z-axis yaw. So this roll, pitch, and yaw, for sensing the roll, pitch, and yaw, we will basically be using this formula to calculate the angle of rotation along y-axis, x-axis, y-axis, and z-axis from the acceleration values. So this is the formula. And here, this is how we are connecting the sensor to the Arduino Uno. The VCC is connected. So this is the Arduino Uno, and this is the sensor. The VCC pin is connected to +5 volt. The ground pin is connected to the ground pin, and this X out, Y out, and Z out is connected to A1, A2, and A3 pins of Arduino Uno. Or if we like, we can also connect them at A0, A1, and A2. Now let us see what will be the program for accelerometer interfacing. Now, there will be two programs for this particular application. One will be for calibration, and the other one will be for testing purposes. Now, this is the program that we will be used for testing. Now, what the program looks like. So there are three different variables: X input, Y input, and Z input. So let us consider that we have connected the 3 pins of the sensor to A0, A1, A2 pin of Arduino Uno. So that is why we are writing it 0, 1, and 2. Next, we are writing constant int. So we are defining a constant integer variable, which name is X minimum. So what will be the value at -1G? So the value has came to 66. And what will be the value for +1G? The value has came for 399. So we want to calculate acceleration for each axis. So that means we have to take values for 0 degree and along x-axis and 180 degree rotation along x-axis. So the 0 degree rotation along x-axis will be considered as x min, and the 180 degree rotation along x-axis will be considered as x max, and corresponding values will be -1G and +1G. So we have to find out what values of x min is coming for -1G, that is for 0 degree rotation, and what value of acceleration is coming for +1G, that means for 180 degree rotation. And we will be storing those values in x min and x max. Now this is for x-axis. Similar thing will be done for y-axis, and similar thing will be done for z-axis. Now these 3 values are measured from calibration. So that the calibration, from the calibration program, actually we will get what are values which is coming for -1G and +1G. By changing the orientation of the sensor in various angles, we will try to find out the value for x minimum and x maximum, y minimum and y maximum, z minimum and z maximum. Once we have finalized the value, we have found out these values, then what we will do is we will run this program what we are discussing now. So we are storing 3 variables: x val, y val, and z val. Now in the void setup section, I am writing serial.begin 38,400. So serial.begin is because I have already told you that Arduino will send the values, acceleration values to the computer with the help of serial communication. So there will be a serial cable. Let me show you the serial cable. So this is the Arduino serial cable. So this is the Arduino Uno. So this is the Arduino Uno. Actually, it is blurring. So this is the Arduino Uno microcontroller board, and we have to connect the serial cable with the Arduino Uno in one side, and the other side, the other USB port will be connected with the computer. Now, so when we connect the Arduino Uno with the computer, the serial communication will happen. When the serial communication will happen, we have to specify at what rate, at what speed of the communication will happen between Arduino Uno and the computer, and which is known as the baud rate or bits per second. So that is why I'm writing this command serial.begin 38,400 means 38,400 bits will be sent per second to the computer from the Arduino Uno, and the Arduino will receive the values from the computer in a similar speed. So the baud rate has been set to 38,400. Now in the void loop section, what we have to do is we have to specify three variables, that is xval, yval, and zval, just what we have declared earlier. Now xval will be receiving the values or acceleration values from the sensor, which is connected to analog input pin 0. So the x-axis values will be stored in xval. The y-axis values from the sensor, which is connected to analog input 1 pin or A1 pin of Arduino Uno, will be stored in yval, and the z-axis values, acceleration values, which is connected to the A2 pin or analog input 2 pin of Arduino Uno, will be stored in zval, and the corresponding command is analog read. So when we write analog read, the analog input is basically read from the pin and is stored in some variable. So in the xval, yval, and zval, in these three variables, the current acceleration values from the sensor is basically stored. Now what we will do is we will convert these values what we have got in the range of -1000 to +1000. That is -1G to +1G. So whatever values we are getting, we will convert them in the range of -1G to +1G. That is why we are writing this command long scale map. So this map command is used to map the variables xmin and xmax to -1G and +1G. So this we perform for the three variables, and we are converting the raw values to milli-Gs. Now, once the scaling is done, all the values have been converted in the range of -1000G to +1000G. That means in milli-Gs. G is the acceleration due to gravity. Now, we have to convert this milli-Gs into G. So we have to map the variables from -1G to +1G. So what we will do, we will divide them by 1000. So that will become in the range of -1G to +1G. That means the acceleration along x-axis, which is actually defined by Axl, acceleration along y-axis is y-axl, and acceleration along z-axis is z-axl. So these three acceleration values are basically storing the acceleration values which has been taken from the sensor, the current acceleration values taken from the sensor along x-axis, y-axis, and z-axis. And then we are writing serial print x acceleration, y acceleration, z acceleration. That means the acceleration values will be transmitted through serial communication to the computer, or to the computer which is running Unity 3D. So to send the values to Unity 3D, or the AR application, we are writing this command serial print, then the variable x-axle, y-axle, and z-axle, and to give us spacing between them, we are using this serial print dot space in between two columns, and then we are providing a delay of 100 milliseconds before taking a new data. So the program has a delay of 100 milliseconds. So this is how the program is running. So this is the main program, which is taking the acceleration values and converting the acceleration values of x-axis, y-axis, and z-axis in the range of -1g and -1g to +1g, and sending those values to the computer running Unity 3D at a baud rate of 30,400. But I have already told you how we have found these values x mean, y mean, and z mean. So we first have to find out, or we first have to calibrate the sensor. That means we have to find out the values for -1g, whatever values is coming for x minimum, and whatever the value for +1g is coming, we have to store it in x max, y max, and z max for the 3 axes. So this is the program for accelerometer calibration. Just a minute. Okay, just a minute. Maybe due to some problem, the video is not opening. I'm opening the video separately. So this is the program for this Adxl 335 calibration. So please note that I have written int x raw min, x raw max, y raw min and y raw max, and z raw min and z raw max. All I have refined to 512 because the sensor outputs the value, maximum value to 512, whatever we are getting. So all the values for +1g to -1g will be in the range of 0 to 512. So basically what we have to do, we have to place the sensor in different alignments, and we have to see whatever values we are getting, but they will be definitely in the range of 0 to 512. So I'm using analog input 0, analog input 1, and analog input 2, A0, A1, and A2 pin of Arduino Uno. I've connected the sensor in these pin numbers. And next, in the void serial begin section, so in the setup section, I have initialized the parameters to serial begin 38,400. And in the loop section, I am reading the serial values, what is coming. And if I press 1, then when I press 1, at that moment, the x-axis, y-axis, and z-axis acceleration values are being taken input, and the auto calibrating function is run on the raw acceleration values. So this is the program. Just let me show you how it performs. So this is the Arduino Uno, as you can see in the inset. I have connected the serial cable of Arduino Uno to the computer. Now when we connect the USB serial cable to the Arduino Uno becomes powered on. This is the Arduino Uno, and I have the sensor is on the back side, which is connected with the Arduino Uno in A0, A1, and A2 pin. So let us see the sensor which is in the back side. So you'll be, just in a minute, you will be able to see the sensor. So I am downloading the code which I have written in the Arduino Ide to the Arduino Uno. So once I have downloaded it, next I will open the serial monitor and I will press 1 and I will click on send to start calibration. So you can see from here the baud rate is 38,400. So I have pressed 1 and I will send. Whenever I send it, so for this particular orientation, the raw ranges for x-axis has been received as 331, 269, 316. So these are for -1G x-axis, -1G for y-axis, and -1G for z-axis. So for -1G x-axis, y-axis, and z-axis, the values are 331, 269, 316. So let us give a 180-degree orientation shift. So you can, I have rotated along an axis of 180 degrees. So this is the sensor, which you can see it in the inset. So this is the sensor, Adxl 335. Now if so whatever orientation was there, I have given a 180-degree shift. And if I again press 1, now it says the acceleration calibration received, and the acceleration values is now 346, 391, and 356 for -0.83 G. So basically you can see there is not much change in x-axis, 331 to 346, and not much change along z-axis, 316 to 356, but huge change in y-axis. So this is basically shift in y-axis. So I have changed along the y-axis and the values has come from 269 to 391. But this is for 0G. We have to find the values for +1G. So I have given another orientation change and I have received. Now the x-axis has changed. Earlier it was 346 and for -1G now it is coming as 268. So, but the z and y-axis has not changed much. So this is how I will be continuously changing the orientation of the sensor. And for different sensors, I will need to find the values for -1G to +1G by seeing those values, and I will be noting down those values for what I am getting. So this reading will be disregarded as this is for -0.46. So we have to find for -1G and +1G. So after performing several iterations of this process, I have basically found for x minimum, the value is coming for -1G is 266, for x maximum is 399, for y minimum is 266, y maximum is 399, and z minimum is 268, and z maximum is 403. So these values I have put in the main program for accelerometer interfacing. I'm downloading the program. This after calibration, I'm downloading this main program to Arduino Uno, and then we will move to the Unity 3D. Now you can see from here, if after I have downloaded, if I change, in the serial monitor, I'll be able to see the acceleration along in the form of -1G to +1G. So the first column gives the values for acceleration for x-axis, second column for y-axis, third column for z-axis. So 3 acceleration parameters or 3 acceleration values in x-axis, y-axis, and z-axis we are getting as I am changing the orientation of the sensor. Now next what we have to do is we have to configure the Unity 3D game environment. So the Arduino part is complete. The sensor values are coming. We can take the sensor values with the help of Arduino Uno, and Arduino Uno is sending those values to the computer through a USB port. Now what we have to do, we have to create a game object in Unity 3D. We have to design the VR environment, and then we have to convert those acceleration values in orientation angle, and we have to attach those orientation values, or we have to pass those orientation values to control the orientation of the game object. So I'm creating a new project by clicking on new. I'm giving it a name as VR Sensor Demo App. Now here there will be no AR camera because the thing is we are not doing an AR application, but we are developing a VR application. So there will be main camera, the scene, and some other assets. So now the scene name is Untitled because the scene has not been saved. So what we will do, we will click on File and first go to the build settings, because if we want to develop an app, Android app or PC based app. So in the builds, and also what I'm doing is I'm giving the scene a name. So I will click on Add Open Scenes and I will specify a name over here. And I will click on Save after giving the name. So I have given the name as VR Sensor Demo. So the scene name is now VR Sensor Demo. We don't need to enable Vueforia in this application. So after that, what I will do is basically to create a virtual reality environment. What I will do is I will import some assets. So in the assets folder, I will go to asset, then import package, and then I will go to environments because I want to use the default Unity 3D environments to design my VR. Though it is a simple VR application, but I will be using there by inbuilt assets. So I'm importing those assets. So once the assets are imported successfully, under the assets folder, there will be a folder named standard assets. And there, if I go inside this folder, which is known as standard assets, there will be environment. Inside environment, there will be trees, terrains, water. So lots of environments are inbuilt environments are there. So we can use these environments in Unity 3D. Now, what we will do, we will try to build a terrain on which the game object will be placed. So I'm clicking on game object and I am importing terrain. Now the terrain is completely white, but we can create mountains, we can create grassy lands, we can create water bodies, rivers, seas in this terrain. So whatever environment we want to create. So I will be creating a mountain range in this terrain to make it a little bit more. I will not say realistic, but to make it more immersive. So what I will do is, so I will create the terrain, but before creating the mountain range terrain, what I am doing over here is I am importing the 3D model of an aeroplane. So I have downloaded the 3D model of an aeroplane from Unity 3D website, and I will be importing that 3D model of the aeroplane in this particular project or in this particular scene. So I will go to import new asset, and inside where I have placed or I have downloaded the aeroplane models. So basically I will be importing the aeroplane model. So the 3 aeroplane models we can see from here has already been imported in Unity 3D. So from these 3 models, I can basically choose any of the imported models. Now also to control the behavior of the game object, I need some programming scripts, which I have already written in C#, and I am placing those programming scripts in a folder named scripts. Now, what these scripts will contain, I will show you. Now this, what this scripts will contain is basically conversion from the acceleration values to the orientation values, as well as the instruction to read the Arduino data transmitted by the Arduino from a serial port, and another programming script will handle the behavior of the game object. Now I have imported a game object as plane, and in this plane game object I will basically import the 3D model of the aeroplane. And so basically the plane has been imported, and the 3D model of the plane will be selected over here. So I'm selecting the 3D model and I'm dragging it in the screen. So you can see the 3D model of the aeroplane has been selected, and the position and the orientation is now being shown over here with the scale. If I zoom it, you will be able to see the 3D model of the aeroplane. So this is the 3D model of the aeroplane I have downloaded from internet. You can make your own 3D model and import in Unity. And I have made the 3D model of the aeroplane as a child of this game object plane. So whatever will happen to the plane, the behavior will be followed the aeroplane object, because this is required for game object animation. Similar to game object animation, we are controlling the behavior of the game object. So now what I will do is I will click on terrain, and I will create mountain ranges in the terrain. In this, so when I click on terrain, in this terrain option, there are lots of settings, and these options are there to elevate a particular section. So I will be using these options to elevate a particular section. And in the setting terrain, I am just trying to find the texture, what will be the texture of the particular terrain. So there are lots of custom provided textures in Unity 3D. You can select any of the texture. So any of the texture of your choice can be selected by clicking on this option settings and then materials. So I'm selecting this texture, and then now I will elevate the mountain ranges. Now to elevate mountain ranges, I have to click on this option, raise or lower terrain. And if I just drag the mouse cursor over the terrain, automatically mountains will be created. Then you can also create grassy lands in Unity 3D. So once the terrain has been completed, then I will place the aeroplane in the terrain so that the main camera can visualize the aeroplane. So when my Unity 3D app will be running, so the aeroplane can be visualized. Now the aeroplane cannot be visualized. The camera preview in the main camera is not showing. So basically I have to change the position of the main camera, or to move it more nearer or closer to the aeroplane. So that is what I am doing. I have selected main camera, and by using this move option, I am basically placing the main camera closer to the aeroplane. So now the main camera can visualize the aeroplane. Now, after this part is done, what we have to do is I have to attach the programming scripts to the aeroplane. So there are the 3 programming scripts I have to attach with the aeroplanes. That is why I have selected the plane and I have clicked on add component and I will go to scripts. And there are the scripts there are the default scripts. So I will go to the new scripts. So let me show you the script. So this is the main script, plane animator, which is taking the data, calculating by reading the input port, calculates the orientation angle and controls the orientation of the game object. So if I double click on it, it will open in MonoDevelop. So this is the script which is responsible. So here it is written public transform plane. So with what this script is attached to, it is attached to the plane, as I have told you, the plane object in the scene. And then there are 3 angles, public float. I have defined 3 angles, public float, X angle, Y angle, and Z angle. So these are the 3 angles where the angle of rotation will be calculated and stored. Now next, here are some commands like, so private Adxl 335 protocol, Adxl message handler. So basically, when we are taking the data from the Adxl 335, there is a formula for calculating the heading of the game object. So from the acceleration, we are controlling the heading of the game object. So I am reading the values from COM port 4 because I have connected the Arduino with my computer with USB port 4. So if you are doing the similar thing, make sure to know the COM port at which port your Arduino is connected to with the computer. So in my case, the computer was connected to the Arduino at COM port 4. So I have given here as COM 4. For if it is connected to COM port 2 in your computer, you will write COM 2. And the baud rate I have defined in Arduino is 38,400. So here also in Unity, I have to define the baud rate 38,400. In both cases, the baud rate should be same. Now, next is calculation of the X angle, Y angle, and Z angle. That is the rotation of the 3 angles from the acceleration values in the range of -1g to +1g received from the sensor. So this is the formula. So if we attach these scripts after importing those models, now it is time to test. So I will go to build settings. I will go to build because I want to build a .exe application. So I am giving the name as VR sensor demo. Now when the application is basically created, if I complete build, now this is what will come. This is the application what I have built. So you can see the way I am changing the orientation of the sensor which is connected to the Arduino. I'm controlling the heading, the orientation of the aeroplane with it. And this is basically done by those scripts. So what is happening over here, when I'm changing the orientation, the accelerations along x-axis, y-axis, and z-axis is changing. Those acceleration values are basically sent, raw acceleration values are basically sent to the Arduino. Then Arduino maps those acceleration values in the range of -1g to +1g and sends those acceleration values to the computer or Unity 3D. Now the program or the script in Unity 3D, this basically takes those acceleration values in the range of -1g to +1g through the communication port, designated communication port, and then converts those x-axis, y-axis, and z-axis acceleration values into corresponding roll, pitch, and yaw, and then it assigns those values to the game object so that the orientation of the game object can be controlled. So here I have made the terrains, and then I have put a grassy land over them so that it looks like a more immersive. So this is how we can develop VR applications, and we can interface sensors, and we can control the movement of the game objects or the VR objects with the help of sensors. So this is all.
Instead of,
And I request Professor BHAUMIK.
now, instead of the accelerometers, okay, so what we can have, yesterday I have shown a joystick. So instead of these accelerometer based systems, if you have a joystick, also you can use the joysticks for giving the commands for the movement of the flight. Okay, so that is also possible. So the
that is for use for the flight simulations.
Yeah, so this is used for the flight simulators. So the pilot must sit, okay, in an environment which looks like a pilot cabin like, okay, and the dashboard, basically the computer screen, so that will contain all the gadgets, means soft part of the gadgets. So it will have a kind of reading, output reading, some for example in the form of dial gauges will be there, or maybe some digital readout will be there. Okay, so that whenever some changes is taking place by hand, the operator is doing, so that is immediately reflected graphically, and also at the same time you can see your movement, hand movement results also you can see it on the computer screen or the computer monitor. And the feeling will be like a person's, those who are operating the systems, he or she will feel that actually he is controlling a flight. So, Shaptak is over?
Yes, sir.
Okay. Okay. So, we try to give you some basic idea of AR and the VR systems and try to demonstrate it. And this is most important. This is most important. Unless and until we write the code, we develop some systems, it is very difficult to feel what it is like. Okay. So absolutely, it is a practice-based type. Okay, lot of theory, lot of PPT slides we can show it, but unless and until, say for example, I have shown you that how your convocations looks like. Okay, convocation system. Let me check that whether I have the video with me. Just to give it time, I will check that whether maybe I will have to check it whether I have this kind of systems or not. Just a minute, I will. Shaptak? Yeah.
Yes, sir.
You have given me the permissions to share. Yeah, I'm sharing it. Can you see this one?
Yes, sir. Yes, sir.
Okay.
As we begin. Technology, West Bengal. I invite Honorable VC Sir, and he is also the founder.
Here is taking
It.
So I'm just showing you the clips.
To you all, we come to have a wonderful evening ahead. Goodbye and good evening.
Okay, so this gives you an information or an idea that how the AR systems, the VR systems, virtual reality. So there is no concept of augmented reality in the last demonstrations, what I have just shared with you. Okay, so that shows you the virtual reality environment. Okay, so it's a graphics, is a kind of graphics works with the sound, and that's give you an impressions like you are really present in the situations. Okay, and nowadays also means the reporters also, so they are taking also the help of the AR and the VR when they are describing the news also. Okay, so they are trying to make the news in such a way that as if you are in the field live. Okay, the people, those who are listening the news, okay, so they will feel, they will immerse in the news event in such a way as if they will feel that they are presently in that situation. Okay, so that way the reporters, they are trying to utilize this AR and the VR concept. And these are means now the news will not be like a simple news like. Okay, it should be an immersive type of news. If there is some sort of, say for example, some sort of disturbances is there, okay, some sort of fightings, political fightings is there, the report should be represented in a such a way that as if you were in the peak, you were at that time, you were there, okay, during the incident at that particular spot, you will feel like that. So there are a lot of means work, people are working throughout the world in different directions, and at least from our presentations we came to know that practically speaking, there is no bar or applications of AR and the VR in either in the industry or in the non-industrial sectors. Everywhere we will find the applications of AR and the VR. And maybe the situations will turn in such a direction that in future we'll have a question in the mind whether we are in a real field or whether we are in a virtual field. So virtual will be so real, it will looks like so real that sometimes we may forget that whether we are observing in a real field, we are present in a real field, in a real battlefield, okay, or we are working in a virtual battlefield. So any questions from the audience?
Any questions from the audience that will be entertained?
Yes, sir. Like, to what extent the AR and VR will give us the real feel of what we do in real world practice as of now, sir?
Please repeat.
Like, to what extent the AR and VR will give you the real feel of what we do in real world practice as of now, sir?
You see that visual informations, auditory informations, they are present right now. Okay, but this is not everything. Like say for example, I have given you another feel, like we must have a touch information. Whenever I am touching something, I must have a feel. I must feel that whenever I am holding a pen, okay, so I feel a touch information. So whatever the surface is, that whether this is a really rough surface or a irregular type of surface, okay, coarse type of surface, so that I can feel with the touch informations. So the touch informations are the haptics information. That means touch and force informations. This must be there in the AR VR systems, and that is totally, we can say that is totally absent nowadays. So whatever the AR VR systems are there, most of the cases it is a visual and auditory. That means the sound. So sound and the visual informations are present, but the most of the cases this touch informations, or that is known as a haptic information, force informations, these are absent in the AR VR systems, and that should be, if we can include that one, so then our systems, the virtual systems, almost looks like a real systems. Graphically graphically the situation is that whether it is real or the virtual, it is very difficult to understand. The graphics has improved in such a way. Okay. So we are unable to understand that whether we are looking at a virtual or whether we are looking into the real systems. Okay. But touch informations and this force information, this is completely absent till today. In most of the applications, 90% applications, we do not have this information. So all the sensory informations, we can add all the sensory informations in the AR/VR systems. So that will become the perfect one. Otherwise, we may have some informations, then we will also think that we do not have some informations. Like if I have a touch informations, but at the same time, if I don't have the force informations, then I may think that something is missing in my applications.
Okay, so thank you, sir.
It becomes realistic. Means graphics is becoming so realistic. Okay, even if I show some picture, okay, I will show you a real picture as well as I will show you a graphical pictures, and you will face difficulties in recognizing that which one is the real and which one is the graphics. Sometimes we also make mistakes. So we think that this is real, but actually this is a virtual. Graphics, computational part, processing part, analysis part, okay, is very fast. Computational part is now very fast. System is becoming more and more intelligent one. Okay, so we have to add more and more sensors into our systems, and the other thing is that our head-mounted display unit, whatever may be, that the cost of that systems must be as low as possible, so that each and everybody can use it. Each and every students can be used it. Each and every faculty members can be given with this head-mounted type of display units. And now only the restriction is the cost part. You will get it not less than like a 30 to 40,000 rupees. So for a headset, okay, head-mounted display units, you have to spend like a 30 to 40,000 units. And the quality of the systems may not be may not be that much of what I say, that not up to the mark. Any questions? Anyone? Any comments from anyone?
Any suggestions from the participants?
And this suggestion is for our
improvement.
To improve our knowledge, our technique, our deliberations, whatever I have shown, whether this is good or bad, or this is very primitive, or this is very what I say, that advanced level. Any kind of information if you provide to us, so that will be better for us to improve our performance in the next time. These are kind of suggestions. Whether we should have more theory, whether we should have more practice, whether we will show more demonstrations, what the participants want, what they feel that if they have given this much of the knowledge in a particular form, so that will be more effective to them.
Sir, I feel this is a very fast growing field, sir. Definitely it's a technology for the present and as well as for the future. So actually we had a lot of people from the school education. They also had contributed. They were also very keen participants. So it has a lot of potential.
Yeah.
There is no sky is limit. Sky is the limit, as we call it.
Yeah.
So that is what we can infer from what we have been seeing for not only user, definitely all other speakers also have given a very hands-on experience to us with regard to this. We have to feel it. That is what the AR and VR is. It's something like we cannot we cannot demarcate. The line of difference is very, very thin, as you would have we have very subtly put it, sir. That is what it is.
Yeah.
And definitely, yes, sir. It's definitely a very topic. It's a very trending topic, and it's very thing for research work, definitely. And we'll want to incorporate more your suggestions, and also, sir, definitely we'll do for the research work to solve any real-time scenarios. As as Mr. Bhattacharya also gave a very good interactive example on this flight simulator. This is what it is. So it has its own scope and it has a lot of potential, sir. Of
And
course,
this is very much useful for the school children also. Means the school teachers and the school children, they must be exposed to this AR and the VR technology.
exactly.
Until this technology, we bring it to the school level, we can understand that if the teachers, they are not using this concept, okay, and how the students will come to know about this technology.
Exactly.
And
Sir.
from the class 1 line, this technology must be available to a class 1 child also at the same time. Okay, so our teaching methods, like say for example, we say like A for apple, B for ball, like, okay, so all these teaching will be done through this AR and the VR concept. We can teach it, and the students can learn the same thing again and again and again. He can learn it. Anyway, means at our time this technology was not there. Okay, and at the fag end of our professional life, we are learning this new technology, but we want to transfer this technology to these newcomers in this particular field. And I hope that those young faculty members, and then if there is any other participants at theirs, I hope that they will use it, okay, as much as possible. And unless and until people work in hands, and they must develop their own course curriculums. Like whatever, if you have in a course curriculum, say 1 or 2 experiments, okay, you show it through the hardware setups. Practically you show it, but at the same time, at least you try to make 1 experiment with this software, with this AR technology. That will be more useful.
Exactly, sir. Thank you, Dr. BHAUMIK, for taking time out. It 2 days have been, I think, a marathon session for you and Mr. Bhattacharya. It's been very wonderful to have you here, sir. It's been a privilege from Department of Mechanical Engineering, Dr.M.G.R. Educational Research Institute, to have you as a resource person. We'll definitely would like to collaborate with you in near future also, on particularly in not only in AR, VR, robotics also. So we'll definitely solicit your advice, sir.
We work basically our field is mechatronics, robotics, industrial automation, CAD/CAM.
Yes, sir.
So this is our field.
Yes,
and this is the new additions. Is AR, VR is the new additions to our research.
Yes, sir. That's true. Thank you very much, sir.
Thank you.
Thank you very much, sir. Thank you. Dear participants, tomorrow the session will start at 9:30, and